Okay, class, look at the question number 2a here. We have graph distance versus time t. For the distance graph, figure 2 represent the motion of a car in 4 seconds. Describe the motion is object. So now, from the 0 to 2, if you look at the graph here, we have an increase of distance from 0 to 20 centimeter. First, you can describe the distance from 0 to 20 meter, or you can describe about them because this is graph distance versus t. If you calculate the gradient of the graph here, the gradient here, we have the gradient, let's say m1, m2, and m3. So we have the single value of the velocity, a constant v. So meaning we have a v constant or uniform acceleration, right? Okay, and for the next second, 2 seconds to 4 seconds, look at the graph here. We have the fixed value of distance. So meaning here for the fixed value of from 2 seconds to 4 seconds here, meaning we have a no velocity. No velocity here is referred to the object is now stopped at the distance 20 meter from the initial position 0, right? And the next is that means the total distance. So what is total distance? So to calculate the total distance here, number 2, right? Sketch velocity versus time. So you convert here graph velocity. So now we have velocity in meter per second unit, and we have the time t here, second. So how to sketch the graph here, because this is the constant velocity. So meaning we have the fixed value of constant velocity. If you calculate the gradient here, because 20 and divided by the 2 here, so we have the 10 meter per second, and we have in 2 seconds, and the last is 4 seconds. And the graph here is constant velocity, and after that, at the 2 to 4 seconds, velocity is equal to 0. Velocity is equal to 0. So this is the graph here. So now, if the question asks you to calculate the total distance for the graph v versus t, you can find the area under the graph here. So we have 2 times 20, or the total distance is equal to 20 meter, right? Okay. Continue to number B. Airplane taking a constant acceleration for distance. So meaning the takeoff airplanes for distance before takeoff distance 280 meter. So let's say this is the ground surface, and this is the plane. Okay, the process of the taking here is the distance is 280 meter. Okay, before the start become airborne. So take off here. So this is the process, where the process here after t8 seconds. Right? On air, this is a ground surface. For this is the plane here at the on air. Yes, so airborne at second. Okay, so calculate speed. The speed during the takeoff. So meaning what is the value of the speed for the takeoff process? So now, because the aeroplane start with the initial value, if start from the rest, meaning the initial value is 0. So the information given by the equation is u is equal to 0, and the distance for the airplane taxiing is 280 meter, and the process for takeoff is 8 seconds. So this is information given by the equation. So now here, what is the v speed here? So if you consider the equation v is equal to linear motion equation for uniform acceleration, v square and the u square plus 2as, and the s is equal to ut plus half at square. So if you look at the equation here, this is equation number 1, equation number 2, and equation number 3. To calculate the v here, you can use the equation 1 and 2, or you can combine both the equation here. Okay, let's say use for the first is because the question not the question gives you the ask you to calculate the v here, so you can use the two equation here. Start with the equation u is v is equal to u plus at, and the value of the vu here is equal to 0. So meaning we have a here, or acceleration here is a v divided by t, right, for the a here. But the acceleration is the same value, acceleration for the second equation here, so you can use the v square u square for the 2as. So you can compare the two equation here, and v here, so u here you also start from the 0, so meaning we have a 0, this is 0, and we have a v square is equal to 2as. So now a here is a v square divided by 2s, right, 2s. But you have a same value of the a here, acceleration, because we have a same aeroplane here, a plane here. So now you can compare to the a here, meaning you have a v divided by t here for the first, and also is equal to a v square divided by 2s. So from here you can find the value of the because v here we can cancel here, so we have v, and here because the time taken about after 8 seconds, so meaning that t here is equal to 8, and the distance here is 280 meter. So now you can find the value of the v here is a 70 meter per second, or the speed during the takeoff is a 70 meter per second, right? So that's all.